entitled Special Right Triangles and Trigonometry. And we are going to answer the question, what connections can I make? So for question number 25, they want us to label the missing side lengths and angle measures of the triangles at right. Then use those diagrams to write each of the trig ratio below as an exact value. When it says exact value, that means they want you to leave it as a radical. Do not take your calculator out and change it to a decimal. Just leave it in the ratios that they want you to leave it in. Okay, so the first one is obviously your 30, 60, 90. So they want you to fill in the 60 that's missing. It has this side, the short leg of 1, so you're going to fill in a 2 for the hypotenuse and a square root of 3 for the long leg. The other triangle is your 45, 45, 90. So one of the 45s they gave you, they want you to fill in the other one. One of the sides they gave you a 1, they want you to fill in the other side of 1. And then the hypotenuse is going to be your square root of 2. Okay? So for the questions below, they want you to do, to get the sine of 30. Okay? Think of this as the address of where they want you to go on either of these two triangles. Okay, because it's 30 degrees, you find it the 30, 60, 90 triangle. You go to the angle of 30, and that's where you're going to take the sine from. So sine is opposite over hypotenuse. So from the 30, the opposite is 1, so that goes in the numerator. And the hypotenuse is 2, so that goes in the denominator. Okay? So its ratio is going to just be 1 to 2. Okay? So whatever angle measure they give you, find that angle measure, and then whichever trig ratio they give you is what position they want you to put the numbers in. Okay? So for B, now we're going to do the cosine of 30. So we're staying right there. But this time, the cosine is the adjacent, so it's going to be the square root of 3 over the hypotenuse, which is 2. And again, they want you to leave it as a radical and not as a decimal. Okay? Part C says the tangent of 30, so same address. Tangent is going to be opposite over adjacent. So we're going to have 1 over the square root of 3. But we also know that we can't have a radical in the denominator, so we have to rationalize that denominator. We learned about rationalizing the denominator last week. Basically, you're going to multiply both the numerator and the denominator by that denominator. So 1 times the square root of 3 is the square root of 3. But the square root of 3 times the square root of 3 is the square root of 9, and the square root of 9 is 3. So that's how you rationalize that denominator, okay? For the next row, it's switching address on us, okay? Now it wants us to go to the 60 degrees, so over here, and the sine is going to be the opposite, which is the square root of 3, over the hypotenuse, which is 2. So notice that these both have the same hypotenuse, right? Because they're on the same triangle, okay? Part E, now we want the cosine of 60. So stay at 60. This time it's the adjacent, which is 1, over the hypotenuse, which is 2. And now the tangent of 60. So from here we want opposite, which is the square root of 3, over the adjacent, which is 1. So it should be the square root of 3 over 1. The third row, now they're going to have us switch triangles to the 45. So now we're coming over here. You can go to either this 45 or this 45 because they're the same. It's not going to matter, right? Because both of the legs are the same. So for the sine, it's going to be the opposite, which is 1, over the hypotenuse, which is 2. And then we need to rationalize that denominator by multiplying both the numerator and the denominator by the denominator. So when we multiply 1 times the square root of 2, we get the square root of 2. And when we multiply the square root of 2 times the square root of 2, we get the square root of 4, which simplifies to 2. Okay? Same thing's going to happen with the cosine of 45. From here, you want the adjacent over the hypotenuse. These look exactly the same. Why? Because the two legs have the same measurement. So that's going to happen. All right, for the tangent of 45, we want the opposite over the adjacent, so 1 over 1. Right? Any questions on A through I? All right. Jumping down to question number 6, it says, examine the diagram at right. Write an equation for the sine of the angle theta and the cosine of the angle theta. Okay, so we don't know this angle measurement right here, so they give it this weird Greek alphabet letter, and we pronounce it theta. From here, the sine is the opposite, which is y, over the hypotenuse, which is 1. So it's y over 1, which you can simplify to y. The cosine of that theta is going to be x over 1, which you can simplify as x as well. Okay? For part B, it says, using your results from part A and your knowledge of right triangles, what is the value of the sine of theta squared plus the cosine of theta squared? And explain how you know. You would take the Pythagorean theorem and you would say y squared, because that was what the sine of theta was, y, so we're going to square it, plus the cosine, which we got x, and square it, equals the hypotenuse squared, which is, the hypotenuse is 1. 1 squared would be 1. Okay? We're going to we're going to squip part C. Anybody still writing part B? All right. Testing examples as you did in part C of problem 26. Can you give an idea of whether a statement is usually true? But to test whether it is always true, you need to prove a general case. Sometimes it helps to start with a theorem that you have already proved. Okay, part A says, write an equation about the side lengths of triangle ABC at right and explain how you know it is true. I just picked the easiest one you know of. Anybody know the name of this guy? A squared plus B squared equals C squared. Pythagorean theorem. Okay? We know it because of a great guy named Pythagoras, right? Okay, so for part B, now you will prove that sine theta squared plus cosine theta squared equals 1. Write an equivalent expression. So I just took the sides. Sine is going to be opposite over hypotenuse, so A over C squared plus B over C squared. And we end up simplifying it to A squared over C squared plus B squared over C squared. And then, since we have the same denominator, we can say A squared plus B squared over C squared. Part C wants you to rewrite it without parentheses, which we already did. And then part D says, what is the expression equal to? And it's equal to C squared over C squared, which just simplifies to 1.